Today we're looking at the law of sines. We've just gotten done with part of the unit on trigonometry. We've learned how to use the trigonometric ratios to find missing pieces. The trigonometric ratios only work with right triangles. So what if the triangle is not a right triangle? That's where the law of sines comes in. So how do I apply the law of sines is our essential question. Your learning intention. I'm learning to find missing measures using the law of sines. So you're starting out with the right triangle, and you're going to find the sine of A, cosine of A, tangent of C, and then the measure of the two angles that are not there. So pause the video and see if you can find the sine, cosine, and tangent of the angles. Well, I hope you try it on your own. Remember our acronym. So, ka, toa. Sine of A. Here's angle A. The sine is the opposite over the hypotenuse. Now we always know what the hypotenuse is because it's directly across from our right angle. So our opposite is 48. Our hypotenuse is 50. 48 divided by 50, both of them have a factor of 2. So that's 24 over 25. Cosine of A, ca, adjacent over hypotenuse, 14 over 50. But once again, both of them have a factor of 2. 14 divided by 2 is 7, 50 divided by 2 is 25. Now we're going to switch to the other side, to the other angle. The tangent of C, toa, opposite over adjacent. Your opposite is 14 and your adjacent is 48. Factor out 2 and you get 7 over 24. Okay, for the measure of angle C, we've already found the tangent of C, so we'll simply use that tangent inverse of 7 over 24. And remember, these are always approximations. Make sure you always close it off. 16.26, which is about 16.3 degrees. Now, to find the measure of angle A, you can quickly put in, let's say, sine inverse of 24 over 25. And you end up with 73.8 or 73.7. But you could also take 90 degrees minus 16.3 degrees and you will once again get 73.7 degrees. So how are you going to do it? Whichever way appeals to you, whichever way your brain sees it. Okay, now that brings us to what happens. What if you have triangles that are not right triangles? There's two different things you can use. One is the law of sines, and the other is the law of cosines. The law of sines is definitely easier to use if you have the right pieces. So if you realize, if this is angle A, this is side A. So the sine of this angle divided by this side is equivalent to the sine of angle B divided by the length of side B, which is also equivalent to the sine of C divided by the side C. If you notice, A, B, and C are lowercase. That means that those are your sides. Those are not your angles. So you can either have it with the sine of A and side A, sine of A top, side A on the bottom, or flip it over. Either set of fractions works. Depends on what you want to do. So if I'm looking at finding the missing measures, I've got to have a matching pair. I've got to have an angle and the opposite side. Now, I've got this side here, but I don't have the angle. How can I find that angle? Well, you'll take 180 degrees and you'll minus 118 degrees plus 22 degrees. Make sure you use parentheses, and you get 40 degrees. So this is 40 degrees. Now, you're always going to use the matching pair you find. So I like to put the sine on top. I'm going to find, this is side A and this is side B. I'm going to find side A first. So the sine of 40 degrees divided by the length of the opposite side, which is 24, is equal to, angle A is 118. The sine of 118 degrees divided by A. Remember how you do that cross multiplication? You multiply at the diagonal and then divide going up. Putting in the calculator, you have got to remember your parentheses. So the sine, you'll have a parentheses 118 parentheses degrees times 24 divided by sine parentheses 40 parentheses equals. These two parentheses are what you have got to remember to put in. Okay, so sine 118. You see how you got one parentheses? We've got to close it off. Times 24 divided by sine 40 degrees. Close it off. And you get 32.966. So it is about 33. Now we don't know what units it's in, so we just say 33 units. I use the same idea to find the measure of B. I start with the sine of 40 degrees over 24 equals, this time angle B is 22, so this will be the sine of 22 degrees over A. You still have to use the exact same math. You'll multiply and then divide. Cross multiplication. The sine of 22 degrees, and that will be in parentheses. Remember this second parenthesis, times 24 divided by the sine of 40 degrees. sine 22, close it off, times 24 divided by the sine of 40, close it off, and you end up with 13.98, which is approximately 14. You found all the angles and you found all the sides. But remember, to use law of sines, you've got to have that matching pair. You have got to have a side and a side that's opposite of an angle that you know. If you've got two of the three angles, you always use the triangle sum theorem. So take a minute and think, how shall I start this? If you said I need to start by finding that third angle, you would be correct. 180 degrees minus 63 degrees plus 101 degrees is equal to. $16 degrees. So that third angle is 16 degrees. Now, if I'm looking at this and thinking logically, my small angle, my smallest side. My bigger angle, my bigger side. The largest angle, the largest side. Your angle measures will tell you which side should be the largest. So as we get ready to start looking for these missing sides, this one's going to be B and this one will be C. To find B, sine of 16 over what? The sine of 16 degrees, and that's got to be the parenthesis there you have to put in, over 9 is equal to the sine, B is 110, 101 degrees over B. Multiply and then divide. The sine of 101, remember the second parenthesis, times 9 divided by sine 16 degrees. Remember your second parenthesis is about. Sine 101 parentheses times 9 divided by the sine of 16. 32.05, so this is about 32. I could put 0.1 if I wanted to go to the nearest tenth. Okay, now what about C? Well, it's the same thing. You start with the sine of 16 degrees over 9 is equal to, this time my angle measure is 63, the sine of 63 degrees over C. Multiply and then divide. Sine 63, close it off, times 9, divide by sine 16 degrees. That'll be in parentheses. You don't put the degree symbol in. Okay, so as I'm looking at this, sine of 63 times 9 divided by the sine, of 16. Close it off. And that gives me, I didn't get my parenthesis in there and it gave me the wrong answer. Okay, the sine, 63, close it off, times 9, divide by the sine of 16 and close it off. And I get 29.09. That's about 29.1. Okay, what happens though if we do not have two of the angles to find that third one? What if we have one angle and three sides? Well, you're still going to set it up the same way. So you've got the matching. We know that this is going to be side B and this is going to be side C. So I'm going to start with the sine of 88 degrees over 26 is equal to the sine of B over 16.1. Multiply and then divide. So 16.1 times the sine of 88, remember that'll be in parentheses, close it off, divided by 26 is equal to the sine of B. Now, once we find that number, to find an angle measure, what do? We use that inverse. So 16.1 times the sine of 88, close it off, divided by 26, and I get 0.61885. You go to out 4 decimal places to get your approximation. So 0.6189 is approximately the sine of B. So I'm going to use the sine inverse, 0.6189, and that will give me another approximation. So second sine, 0.6189, close it off. It's approximately 38.2 degrees. Okay, now, it is definitely easier to use your triangle sum theorem for the last one. So to find the measure of angle C, I'm going to take 180 degrees minus 88 degrees plus 38.2 degrees. And you end up with 58.8 degrees. Okay, are you going to get the exact number on your angles? Usually not, but you can do an approximation. So the first ones we had pictures of. But what if we don't have a picture? What do we do then? Well, we draw it. Triangle ABC. This is 145 degrees. This is 33. Angle C, side C. This is 7. So, where do we get started? We still need angle B and we need side A. And angle A. What do we do first? Well, you're actually going to have to find angle B first, because you've got to have angle A to be able to find the two matching pieces there. So to find angle B, we have to do the pair that's angle C and its side. So the sine of 145, and that's degrees, over 33 is equal to the sine of B over 7. Look at how it's set up and think about where everything goes. Start off with multiplying. Whoops, wrong way because I don't have a number there. So I'll take 7 times the sine of 145 and I put that second parentheses in, divided by 33. And I get 0.12166. So this is approximately 0.1217. I use my sine inverse. 0.1217 and the angle measure is about 6.99, so that would round up to 7. Now, I have to find the measure of angle A. You find the measure of angle A by using your triangle sum theorem. (180 degrees minus 45 degrees plus 7 degrees and you end up with 28 degrees. Okay, now we can finally find the measure of angle A because we've got those matching pieces. You always go back to the original because with the original you have not estimated, you've not done that approximation. So that will give you a much better number without the rounding error. So we start off with the sine of 145 degrees divided by 33 will be equal to the sine of 28 degrees divided by A. multiply and then divide. So the sine of 28, close it off, times 33, divided by the sine of 145, and again you'll close it off. And you end up with about 27.0. So A is approximately 27.0. Okay, the hardest part is to remember to close off your parentheses when you're doing this. If you don't, you get really weird answers like what I did when I forgot. So make sure you're closing off with the parentheses. How do you know you're successful? You know you're successful when you can solve non-right triangles using the law of sines. So this is all about the law of sines. All about those equivalent fractions. The equivalent ratios.